Last time we talked about infecting the system. True, we talked about viruses and worms and Trojan and those sorts of things. Today we want to talk a little bit about how to prevent those things from happening to you, hardening the systems. The best way to harden the system is to update the system on a regular basis. Virus checkers, anti-spyware, those kinds of things. What kind of add-ons do you put on your machine? What are the implications for Java, JavaScript, and ActiveX? Each of them is a little bit different than the other. So those are the kind of things that this chapter is about. The objectives explain how to harden operating systems. When we talk about hardening an operating system, and we'll do the lecture and the objectives and then go through the 60 slides to see what I missed. What would you do to harden an operating system? What does that mean, harden the operating system anyway? Make it hard to get on? We did that already, right, Brandon? Made it hard to get on? We got the system hardened. Huh? Say what? Get rid of all unnecessary programs. That's exactly, all unnecessary services. Each of those services, remember, and we'll get to port scanning later on, each of those services, well-known services, represent a port number, a socket, an IP address, and a port. Are there exploits for all of those ports? No. Are there exploits for a lot of those ports? Yes. What if you, we'll pick on Matt here in a minute, what if you all of a sudden did away with your remote desktop port open on your machine, because he's told me that it actually improved things on a computer. Does port 5190 have some vulnerabilities? Probably. Does it have exploits? Probably. What kind of things can you and can't get, huh? 50, what did I say? 3190. Oh, 5190. Yeah, 5190. RDP.
3189.
3189. Oh yeah, that's Squid Proxy, isn't it?
RDP is
3389. Yeah, thank you.
Anyway,
yeah. 5190 is VNC. True, I think. But each of them has its own service, and that's what the scanners are looking for, is an open port. If we allow that through the firewall, if we allow that service to go through the firewall, then they can sit there and scan for that. And they do. Yes, they do. So, like Adam said, what we want to do is turn off all those unnecessary programs so that we minimize, reduce what's called the attack surface. Fewer things to attack. Back to the age-old question, why does Microsoft attack so much? Because there's so many of them. If there were as many Linux machines, they'd be attacking Linux machines. If there were as many Macintosh machines, they'd be attacking Apples. So we're going to do that. List the ways to prevent attacks through the web browser. Now, I think this one they have you go through and configure the security. It's a good idea to do that. The default configurations are okay, but may not be as complete as you want. I think, for instance, one of them is to delete the cookies is not, that is a configuration that you can do, but I don't think it's the default yet. They've changed, and they do change with each update what the defaults of a lot of this stuff are. What are you going to allow your browser to run unsigned applications, unsigned ActiveX, unsigned Java? You probably shouldn't, but what are the defaults? What changes do you need to make on your browser? And in a larger sense, what changes do you need to make to your policies if you're managing a network, an Active Directory network, as we go through those things? So minimize those. Define SQL injection and explain how to protect against it. There is a piece of open source software that does some really cool stuff, demonstrates this, and I've got it, and I'll set it up so that maybe we can use it in here, but you can get it on your own if you'd like. It's called WebGoat. What WebGoat is an intentionally insecure Apache web server that demonstrates a number of internet attacks, how they take place. They're not sophisticated attacks, but it goes through how you do SQL injection. How do you scan a web page for something that a developer may have left an open username and password on? It's kind of an interesting little piece of software, but how do these things work? SQL injection, this is going to be in your databases, buffer overflows and those kinds of things. How to protect systems from communications-based attacks, various software security applications. Hardening the system, I guess this is the first one. Hardening the operating system to resist attacks is three-pronged. Updates, buffer overflows, protecting against buffer overflows, and configure the operating system protections. If you think about it, and I've seen a couple of pyramids. One of the pyramids starts out with updating the operating system as the first layer of the pyramid. Because if the guy that's responsible for that doesn't do the updates, doesn't matter what you do, defense in depth or anything else, if you have those vulnerabilities there, you have those vulnerabilities there until that basic operation's taken care of. So updates, Windows updates, automatic updates, however you're going to do it, is really a very vital thing that has to happen. Buffer overflows, this is typically going to be a programmer issue, and we'll blame James for these since he is a programmer. Well, I don't remember the number. Do you remember the number of errors per lines of code that is the published numbers? Anybody? I think it's like one error for every 50,000 lines of code or something like that. I mean, just that errors people make, not from things that people may have done intentionally. What a buffer overflow does basically is fills the buffer up. Remember, buffers are small areas where information is stored temporarily. Buffer overflow overruns that buffer, puts more information in that buffer, pushes it out, think of it, pushes it out the top into RAM, and it may push it into a particular area of RAM to where you've got a hook. And they talk about here in a minute the return address in the header, so that you make the return address your address so that you can capture the operating system. And I've been told, not being a programmer, but I've been told it's a real simple way to fix that is you just have to have a truncate command at the end of the line so that it won't allow the buffer overflow to take place. But these are all realities. And you see how easy it is to hack systems. And buffer overflows are one of those things. Does that mean that it's just out there forever and ever and ever? It goes back to the same, you've got to have an opening, scanning, port scan, find an opening. You've got to have a vulnerability. You've got to have a port that's open that has some weakness. And then you've got to have an exploit. What if they fixed the buffer overflow? What if they fixed this or fixed that? That's what all of the updates are about. And many of the updates, maybe even be able to say most of the updates revolve around the web servers, web browsers, because those are the most exposed areas. I think they talk about, and I think the number is like one programming error on average for every 50,000 lines of code. And then you get a couple 100 million lines of code, that's a lot of mistakes that can happen there. Configure the operating system protections. These are things like the firewalls that are built in, whatever else might be available. Update. Writing a secure operating system is daunting due to the increased length and complexity of the operating systems. And I think the next slide's got the table that's in the book about how many lines of code are in an operating system. And you say, oh, Windows is the biggest. And not exactly. Debian, I think, has got 284 million lines of code.
238.
Huh? 238 million lines of code. How much does it say Vista has? Because that's the one that's there. 50 million, right? 50 million lines of code. So if we have one error for every 50,000 lines of code and we got 50 million lines of code, how many mistakes are in there to start with that are unknown? Thousands of them. Are they all things that can be exploited? No, otherwise we'd have a tremendous number of exploits. But the crackers, the criminal hackers, are out there looking for these errors, for things that can be exploited. So the increased unintentional vulnerabilities are introduced, the 0-day vulnerabilities that are there. What was it, 2 years ago at the Hackers Convention, DEF CON I think is what it's called. Guess which was the first operating system hacked? They had, or I guess it was they had Linux, Vista at the time, and Mac. Which do you think was the first one hacked? Mac. You knew that you've heard the answer before. Mac was. How did it get hacked? A 0-day vulnerability in Adobe Flash. Something that hadn't been fixed, because you see those updates come on a regular basis too. Flash updates, Java updates, on and on and on and on. It's not just the operating system, it's all the add-ons that go with the operating system.
I just basically tell your Mac people say all the time they don't get viruses.
They don't get viruses. If they don't, I know, yeah, they don't get viruses, except they do now.
Well, not that they don't personally, that their computer system is not capable of getting viruses.
Oh, yeah?
Yeah.
There aren't many, but they are there. Why aren't there many Mac viruses? There's not enough. It's not worth the effort. It's not worth the effort. The Linux, by the way, it took them 24 hours, I think, to hack the Vista, and then they said they didn't hack the Linux, but they probably could have, because they would have had the same Flash vulnerability as the Apple did. So what's there, what do you got to do? When we talk about updates, it's not just the operating system updates. The applications, all the other things that go along with everything that's running on the machine can have a vulnerability. So we have these things. This is the one that's in the in your book. Linux kernel version 2.6 got 5 million lines of code. FreeBSD 9 million. Red Hat version 7 30 million. Mac OS 10 86 million, and Debian 238 million lines of code. That's a lot of code, huh? It's a Linux release. It's a Linux system. And just different ones of those. Those are the estimated lines that are in there. And some others. Back here at MS-DOS version 1. All of 4,000 lines of code. NT 6, 10, 11, and you see, and that makes sense. As they do more, you're going to have more code in them. And as you have more code in them, you've got more possibilities, probabilities of errors in the code, and you're going to have more errors in the code. So terminology, and these are the things that we talk about. Security patch, general software security update intended to cover vulnerabilities that have been discovered. So a security patch is something that applies to everybody. Hot fix, and what I'm trying to do is distinguish between a security patch and a hot fix. A hot fix addresses a specific customer situation. Often is not distributed outside of the organization, or if you have that problem, and sometimes I go find Microsoft issues that we're having, and there is a hot fix that's not available publicly, but you can email them and they'll let you have the hot fix. So if you run into things like that, there may be a hot fix, not a patch that is distributed to everyone. And sometimes the hot fixes become so much in demand that they do distribute them. The other one's a service pack. Service pack is a cumulative package of all the security updates. What it does is take everything up to a certain point, rolls it into one package, except for XP Service Pack 3. Generally, if you put XP Service Pack 2 on it, it includes everything that's in Service Pack 1. Service Pack 3 in XP does not do that. You have to have Service Pack 2 on before you can put Service Pack 3 on. But generally, you can take the latest Service Pack and it'll bring you up to date, to that point up to date. You can look at these things. These are the terminologies for the critical, what each of these things mean. Not generally, critical updates are the ones that you probably should just, even if you control what happens, you probably should let them be installed. What I want to do in a few minutes at the end here is go look at WSUS, the system that Windows uses. Windows provides us to distribute updates to large numbers of machines. take a look at the one that we use here. Feature packs, updates, patches, hot fixes, update roll-ups, and service packs are all parts of updating the system. Patch management, you do this at home. Who does them automatically? Who doesn't do them automatically?
I have it set for, it tells me when they're available, and I choose.
Yeah, and then you choose what. When we talk about my individual computer, I probably don't have anything that is a custom software James made because he's a programmer. But custom softwares are things that can be broken by these.
I have learned my lesson. I had my server steps do automatic updates.
Yep.
And when they automatically pushed out IE8 on everybody, it broke a bunch of plugins.
Yes,
on the server.
it did. It did. And it did here too. And that was one of the things that WSUS allowed you to do, was to say don't install it. And one of the things it does allow you to do in your network is allows the network administrator to pick which updates get installed to the machines. Ours, we do the security updates. We just have them happen. And then we have different groups. We have the client machines, and we have the servers in separate locations. And the servers are broken down into domain controllers and member servers. What do we want to happen with each of them? And it may be different. What we used to do is we had one domain controller. We had two domain controllers, or three. We actually had three. One of the domain controllers, we would let it install the update, see if it broke it. If it did, we still had the other domain controller. One of the other things that you need to be careful of is particularly the servers, and James was talking about the server, and particularly servers, is to be sure that there's not a prerequisite for installing this particular one. We had a network administrator that killed Exchange server because this patch came out, put it on. Problem is he didn't read the fine print. Well, not really the fine print, the instruction print, which said be sure you have whatever on before you do this, and otherwise it's going to kill Exchange. Well, guess what? It wasn't, and they were right. It killed Exchange, which is a real pain whenever your email server goes away, just gone. But watch those things. So we can install the updates automatically, download the updates, and let me choose. If you do that, go back and check and actually check for updates and let me choose whether to download and install them. They're not automatically downloaded, and never check for updates if you want to be insecure. Are there any instances where you might never check for updates?
Yeah, when you got a bootleg version.
A bootleg version? It's kind of a catch-22, but what if you have machines that don't ever get on the internet?
Yeah, you won't need it.
Do you need the updates?
Probably not.
Probably not. Do you need a virus checker if they never get on the updates and never get on the internet? No? What if somebody plugs in a flash drive that's got a virus on it?
Yeah, you're screwed.
I mean, the right, wrong answer is what's the circumstance that you're in. Most machines now, I think, are on the internet. Although there are some companies that completely isolate their databases, their machines, and they only use what is there. So each of these, and you can do the same thing in WSUS, install them automatically, download and wait, or tell me that there's stuff there and let me go get them myself, or just leave me alone. Patches can sometimes create new problems, and James talked about that. I gave you an example of that. And sometimes the patches create different vulnerabilities if they're not properly tested. The other thing about this is an area where virtual machines can probably be really handy for you. If you've got a virtual machine that has all of your applications on it, your specialized applications, try the patches out on it before you distribute it. And it's always a good idea to try it out on something before you send it to the whole company. Some of them can be undone automatically. Some of them can't be undone automatically through WSUS. So what does it do? What's it going to do? Test it before you send it to your 6,000 computers and break them all. servers themselves, you probably should look at what it does and what are the prerequisites for it to be installed. And that's one that you can, that's another one that you actually could have a virtual machine. There are softwares, by the way, that will take a physical machine and virtualize it for you so that you can have an exact copy of what you're doing. VMware does that. Microsoft does that too with the virtual machine manager. Well, it's not free. They have this, oh, it's really cool. You go to the internet, there's this really cool application you can virtualize into that. VMware, what I typically do with VMware is I will go take the physical machine and make it a VMware, and then I found an open source piece of software that will convert the VMware disks to the VHD disks, and then I can run it in my Microsoft system. So you can convert those things. You can convert the disk types if you want to. This is what you're going to see in the Windows 7. This is actually out of Vista, but Windows 7 looks the same way. Control panel, managing when you're going to do your updates. This is going to be for your home computer. If you look at the one here, I think you'll find all this stuff's grayed out. And you can take a look at that. That's one of the policy things that, yep, do we want users being able to change these things? Probably not, because it is kind of annoying. What our policy does, we use policies to do this. The reason that, and many of you heard this story before, but the reason that we want the machines on, we've taken away the shutdown button when the policies are applied correctly. You have a log off. We want the computers to be running at 10:30 at night because a number of things happen. One of the virus checker runs to check the disks to see if any of them have become infected during the day. The second thing that happens is the machine, there is a policy, an update policy that checks to see if there are any Windows updates. And if there are, it automatically installs those updates at that time. And then after that, there's a script runs that shuts down the machines. And then in the mornings, the BIOSes are configured to restart them. Huh?
How come some rooms random machines are always running in the morning? Like the rest
It just, well, they all should be if the BIOSes are configured the way we want. I think all the machines in here are running except that one in the morning. Is that true? Nobody sits there anymore. Joel used to come in and sit there. Are your machines on when you come in the morning? That one's not on? Oh, yeah, it is. You just got to wake it up. Huh? They do. They come on at about 7 o'clock. Unless somebody's been into the BIOS fooling with them. But they do go to sleep after a little bit of time. And they can go into a relatively deep sleep. But I think that they are on. Yeah. Windows 7 has got this really let me go to sleep thing, right? Like you and I would like to do right now. So, but you can configure that. The reason is some of them are on, some are on. It just depends on how the BIOS is configured. Can you use the operating system to turn the computer on?
The timers are
If
wake-up timers are allowed, but you have to have S1 and S3 in your BIOS.
oh yeah, in your BIOS. So we're still using the BIOS to load that. That was my trick question. And Monty's looking at me like, wait a minute, the operating system's not running. How's it going to turn it on? And I agree with him. We have to have timers in the BIOS. And you can configure the BIOS to turn the machines on. And these BIOSes like every day, and they're supposed to come on every day, but not on weekends. And then they do shut down with a script. The operating system is running, so we use a script to do a shutdown of them each night. But that's the why we want them on, so they do stay up to date. Go ahead.
I mean, you can do wake-up timers as long as it's in hibernation or it's in sleep.
Hibernation, yes, I agree. Hibernate or sleep. I agree, absolutely.
My server cuts on every day at 5 o'clock.
Yep. Out of hibernate.
Wouldn't hibernate have to be in the BIOS too? Well, hibernate, it cuts it off all the way.
Well, kinda. That's what I thought too until I got this antivirus checker that said, hey, wake it up to install it, and it does that. I got one that hibernates, and every Saturday morning it wakes it up to run the virus checker. Again, and this is not a new machine that it does this on, but it's out of hibernate. I agree with you. and going to sleep or standby, the processor and all that other stuff's running. It's just at minimal consumption. But some things will wake it even out of hibernate. So what do you want to do? How do you want to manage? Let's see if I can get back to where we were. How you want to manage these things? But we want all of the machines to be up to date. That's why it goes through this process. We want to be as secure as possible. Why we have this process set up when nobody's on the machines after night classes are over, so that it goes through and checks itself to see what's going on. Automatic patch update service. This is the one I've been talking about. Windows provides this thing for the Windows machines with WSUS for a network. All of them, Linux included, have automatic updates. That's what used to really frustrate me about Ubuntu. I didn't use it all that often, but every time I turned it on, it had 4 or 5 updates that needed to be done. Huh?
What were you using?
Just to learn how to use it.
I don't particularly like Ubuntu. I don't know why.
Well, it's okay. To me, all Linux is about, to me personally, all Linux is about the same.
Yeah, I guess the layout maybe I didn't.
Yeah. I just to use it for a while to see what you could do. Because I always thought it was kind of neat to be able to manage my Windows servers off of a Linux machine through remote desktop, because it's a standard protocol, and you can do that thing just like all you guys with smartphones can manage your servers from your telephones. Chris is doing that.
Can't get mine to work.
Can't get his to work though.
I've worked on that.
Yeah. Automatic patch update, and what the automatic patch update does, WSUS, we have a server designated as the one that goes to Microsoft to get the updates. So it uses the wide area network bandwidth. Only one machine has to contact Microsoft, and then it distributes the updates within the network at local area network speed, 100 megabits per second or gigabit, depending on what kind of NICs and what kind of communication you have inside your network. We're presuming that we're beyond 10 meg for these things. Computers that don't have internet access can receive updates, and we could do that. This is kind of one of the later on questions that Microsoft likes to ask on their testing. Is you've got machines that are got to stay off the internet, but you want them to be updated. How do you do that? Well, you don't let them on the internet, but you let them contact your WSUS server to do those things. And huh? You could, but I mean, huh? Will they update? I guess I don't understand your question. If I didn't want them on the internet, I wouldn't let them on the internet. But if I want them to be able to be updated, I would let them contact the WSUS server. Then they wouldn't go on the internet. The WSUS is in my local network. So did I miss something?
No, I'm good.
Okay. The other advantage, and we'll look at that, is administrators can approve or decline updates. You can say, yes, I want them, no, I don't. Or you can just hide them and I want them to come back later. What we did, and James was talking about IE8. IE8 did a number of things to us also. There were some online course material that the publishers had warned us, do not put in Internet Explorer 8 until we have made some changes to the websites for the courses. So when it came in, we said, don't install it yet, and we just kind of put it in hold until they said, okay, we've made the changes now, go ahead, and then you try it on a couple of machines to see if they really do work before you distribute it to the whole enterprise. Specific types of update the users are not tested can automatically be installed whenever they become available. So one of the things that we do is the security updates we allow to go in automatically. Some of the others you may want to test them and then apply them later. It depends upon what you want to do. Again, is there a right or wrong answer? No, it's just what works for your organization. How often do you do it? We have it every 24 hours. Every night it checks to see if there are updates. You don't have to. You can check it once a week, once a month, because Microsoft typically sends patches on Patch Tuesday once a month, except when there's something really bad and they have what's called an out-of-band update, which means that it's not on Patch Tuesday. It's so important that we send it anyway. The other thing here on the advantages of doing it automatically, users cannot disable or circumvent updates. And I think that if you go to your control panel on your desktops here, you'll find out that you can't change the updates. I can't change the updates on mine because they're controlled by policies, controlled centrally. This is just a picture of how this thing updates. Automatic patch update server. Windows World WSUS is the name of the server. It goes to get the updates, and then it distributes the updates to the individual machines. This shows two servers. You can use the WSUS server. You can update the database of a second server from the first server. If we were in centralized management and we, as the enterprise, wanted to control what updates went to all of our sites, we could do that by configuring it so that our WSUS server went to Microsoft, got the updates, we approve the updates, and then everybody else's server updated from ours. So you have quite a bit of flexibility in this thing. Buffer overflow, we talked about that a little bit earlier, occurs when a processor attempts to store data in a RAM beyond the boundaries of the fixed length storage buffer. Put too much information in, it runs out of the buffer, simplistically stated, out of the buffer into RAM. The extra data overflows into adjacent memory locations under certain conditions may cause the computer to stop functioning. Again, just because there is a vulnerability does not necessarily mean that there is an exploit in any of these things. Buffer overflow in order to compromise a computer. And this is the process. We have program instructions, buffer storing, integer data buffer storing character data, and then a return address pointer. The return address pointer brings it back to the program instruction. True? Supposedly. Well, sort of, kind of. Program instructions, buffer storing, we'll put the malware in here. The new pointer brings it back to the malware, so the malware can take over the processing of the machine. Basic defense, write defensive program code, will protect it, use programming language that makes these attacks more difficult. I think what this is basically saying is you got to trust the programmer. Because, I mean, you have to pay attention. Are these programs good? Who's writing the programs? Are there any indications once you get a program written for your company that these kinds of things are happening? You've got to pay attention to what's going on.
For the network where I'm writing now, anything don't match types of data that's coming in, it just dumps it.
Just dumps it, yeah. And I mean, that's a safety written into the program itself. How many of you could do that? How many of you could check the code? Not me. No? So you got to get these programs from reputable users. Do even the trusted providers, are they always absolutely 100%? Now, a few years ago, many years ago actually now, Microsoft released a bunch of software viruses in it. Inadvertently, obviously, but they did. So, and I think sometimes the programmers, and James can help me out here because, again, he is a programmer, sometimes it doesn't do exactly what the programmer expects. Many times it doesn't do exactly what the programmer... What happened here? Huh?
Iterative
yeah.
programming.
Yeah.
I don't work. Debugging.
Yeah. This is something, Windows-based systems, two defenses against them. The data execution prevention, DEP, is something that was added with Service Pack 2, I think, XP Service Pack 2. So you should be able to use that on your XP machines. I think they've got Service Pack 2 on it. If there's not, the Service Pack is on the, I think it's on the default gateway. And address space layout randomization. What this does in the book, it says that what it does is randomly puts parts of the program into memory so that the odds are reduced significantly that there will be a predictable location. And a lot of security is that. What is the acceptable risk? How can we minimize the risk? Because you can't make them absolutely secure unless you just don't make them. But DEP configures it to not execute programs, and the default is just Microsoft programs. You can go in and configure it. And I think that one of the activities at the end of the chapter is to configure depth. Most CPUs support a no execute to designate them. Will not allow code in the memory area to be executed. Vista allows, and then Vista read XP Service Pack 2 on up to enable the hardware protection specifically for application software that they develop. There are two options in there. One is for Microsoft only, and the other one's for everything, including the Microsoft stuff. So here is the window that you'll see for essential Windows programs. Turn depth on for all programs and services except those I select. It can break some stuff. If it breaks a program, you can make an exception in here, and typically in security you're going to have a general rule, yes or no, and then have exceptions to the yes or no. And this says no except for the exceptions that I put into the system. Address space layout randomization. Randomly, I can't talk this morning, assigns executable operating system code to one of 256 possible locations. And I think with 256 possible locations gives you a 0.39% probability of being able to find that exact location. Harder for the attacker to locate it, most effectively when it's used in conjunction with depth. So you've got two things to help protect it. Four-step approach to this: security configuration, configuration baseline, security template, and deployment. What does a security policy do? And policies are Chapter 14. We'll do more on that, and you will get to do more on that later in the course too, like write a security policy. But why do we have a security policy? And what do policies do?
So the organization has a set guideline or procedure.
Set a guideline or procedure. What's the security policy at the bank? Huh? What? Now, what is his ID, a set of rules? But what can you or can't you do? Let me get back here so you can talk into this thing.
Can only take your money.
Can only take your money, but these guys work in the help desk, the data center areas, right?
Your money. Your money.
But what kind of? Do you have any restrictions on what you can or can't do on the machines? Mm-hmm. Like what?
Can't download anything.
Can't download anything? Why would that be?
If I download a virus.
If you download a virus, what if we download a Trojan? What if we download an AMI admin and just let somebody just take control of the machine? Well, what do you want, and what is the policy? And you probably have a little policy that you kind of do on your own at home. But security policies, what can and can't we do? And there are lots of different policies, acceptable use policy, physical security, on and on and on. Configuration baseline. Why would we care about configuration baseline? What does that mean?
We know what
What normal is. And we would kind of like to have everything to be normal, and that's where the security template comes in. We can use the security template to create a security policy in Microsoft anyway that we can either take to all the machines and import that policy or distribute it as an Active Directory policy. And then deployment, we actually, after we have tried it out and find out it doesn't break everything, we'll deploy it to the systems. Browser attacks, cookies, JavaScript, Java, ActiveX, and cross-site scripting. Each of these things are configurable in the browsers. Each of these things have, I guess, different issues with them. Cookies are inherently dangerous. By themselves, are they dangerous?
No.
What are they? Cookies are computer files that contain user-specific information. What the heck does that mean? Where you been? What it is any configurations that you make on the page that you've been to, because they are page specific. First-party cookies and third-party cookies. The first-party cookie is one that the website that you went to put the cookie on. The third-party cookie is some other site trying to use that cookie. and that could be to get information. Can pose a privacy risk, can be used to track the browsing, buying habits of users, and that, you notice there's a continuing theme here of the browsing and buying habits of users where you're going. There's a huge market in advertising, and that's what they're trying to do, is to target advertising to get you to buy stuff. Same reason that people are sending spam, isn't it? Why do they send all this spam for you to buy stuff? Because somebody's buying it. Defenses include disabling the creation of cookies or deleting them once they are created. And I think that one of the Internet Explorer configurations, probably Firefox too, is to delete the cookies whenever you close the session so that they do go away. JavaScript, Microsoft's a scripting language, does not create standalone applications, and the next thing is going to be Java. This is the script itself. Computer programming language is typically interpreted into a language that the computer can understand, so we're doing scripting on the machine itself. Automatically downloads and runs it on a local computer can be dangerous. This is the one I think they talk about, the drive-by viruses, where you go to a specific, even if you, sometimes you just roll your mouse over a specific location on the web page and you can get infected from these kinds of scriptings.
With the torrent sites are like...
Torrents kind of tough torrents are kind of tough, and they address those. And the reason torrents are kind of tough to send a virus is because you get different parts of the program from so many different locations, unless everybody's got the virus. Peer-to-peer virus is easy to do because you get the whole file from a single location. But the torrent, splitting it up between however many machines are in the swarm, doesn't prevent it, although I think the book says you can't get it. I know you can get it, but it reduces the risk anyway because it comes from so many different locations. So this is the web server, the browser, the HTML document with the JavaScript downloads the user's computer, and then the script runs. If it is a harmful script, then it's a harmful script. What kind of authority does this program have? Whatever you're using. It won't have administrator unless you're logged on as administrator, won't? If you're logged on as regular user, it's got regular user, restricted user permissions. If you're logged on as administrator, it's got administrator permissions. And that's another theme that I keep coming up with, trying to convince people that it's not always a good idea to be the administrator.
I've seen some of them where they actually get like temporary internet files, and then some type of system, the system actually scans them or something,
Yeah.
And it executes the version.
Yeah. These can be, prevent them. JavaScript does not support certain capabilities, has no networking capabilities. Every time does not, cannot, will not, somebody makes those statements, somebody will find a way around that cannot, will not. I prefer the probably won't, most cases, many cases, rather than trying to make absolutes, because a lot of things that absolutely positively couldn't happen, going to happen. You just have to be aware of what's going on and how you configure your browser, any of the browsers. JavaScript programs can capture and send user information without the user's knowledge or authorization. This is a pretty big deal. Can capture or send information. Information out of the cookies that you may have put in, maybe other information that's on the desktop, email address lists so that you can become the spammer. To disable it within the web browser, so you can disable scripting, or at least tell it to ask your permission before it executes. I think you can enable, disable, or request permission to run, so that you know that you did it to yourself that way. Java is an object-oriented programming language created by Sun, can be used to create standalone applications. These are applications that run on the computer, but they run in a sandbox. They can't access other parts of the computer, whereas the JavaScript can. A Java applet, separate program stored on the web server and downloads the user's computer with HTML. can also be made into hostile programs, but again, Java does run in a sandbox. Sandbox is a defense against these, surrounds the program and keeps it away from private data resources. Sandbox is a term you'll hear, which means that it runs in its own little area, and it can't get out of that area. Unsigned and signed applets, and these are, again, are configuration changes that you can make in your browser. Do you want to allow unsigned applets or signed applets or any applets? Your choice. Yes, yes, no, ask me kind of questions. This is one that is kind of interesting. I thought the window that pops up. This looks really authentic, doesn't it? Like you've lost your connection. This is, in my opinion, not a real good warning applet window. This message indicates that this dialog box is produced by an unsigned Java applet, not you've lost your connectivity and you need to log back on. You put in your username and password and you've just given it away. Warning. I guess anytime there's a warning, you may want to find out what the warning's about.
It's the easiest way to get the information is ask for it, right?
Okay, tell me what your username and password is for your banking account. Okay? Huh? You don't have an online banking account?
On purpose.
On purpose. Well, where's your banking account? I bet we can get you one. I bet we can get you one. I know, but we do. We want you to have one.
Sorry about the luck. This is James Wood. I would like to set up a bank account.
Yeah, online. I like online access to my banking account. But how do you protect all of this information? I mean, there's just so much of it out there available. Well, you have to, and you have to be a pain to protect it. How do you do things? What information does somebody need? That's why, see, we'll get some information out of James here. We'll set him up an online checking account and have a party.
As long as y'all put money in it, it'll be all right.
Oh no! It only goes one way, and that's not the direction. Yeah, do you have overdraft protection? ActiveX is Microsoft's set of technologies. One of the differences between ActiveX and Java runs in a sandbox, ActiveX does not. ActiveX gets access to the entire machine. Back to the who are you running the browser as, how much access does it get. And you see that kind of here when we change the virtual machines, it has an ActiveX control. It has to be put on. You as an ordinary user, you as the regular users can't put it on. Somebody with administrative authority has to start it. ActiveX only has to be installed one time on the machine, not one time per user once on the machine, which means that it can be put on by, depending on how the browsers are configured, by somebody else and actually affect other users that use that same machine. They talk about shift work, but in here we got day students and night students. You put something on the machine, it's going to affect the night student. Not a programming language, a set of rules on how applications share information, also called add-ons. A specific way of implementing ActiveX can perform many of the same functions as Java, but do not run in a sandbox. Full access to the operating system. And I think that's the thing to really take away about ActiveX. Yeah, it's really cool, allows us a lot of stuff to happen. It is a set of controls, but it does not run in a sandbox. It only has to be installed once on the machine, and it gets full access to the operating system. So whatever user you're using to run these things, that's the authority that you get in Windows. Nearly all mechanisms are set in Internet Explorer. Controls do not rely exclusively on Internet Explorer, however, can be installed and executed independently. ActiveX, actually there is an IE tab now there's one for Chrome and one for Firefox that both will allow ActiveX to execute in those programs if you make a conscious decision to run the IE tab. Non-Internet Explorer browsers, unless you put these add-ons in the other browsers, ActiveX won't execute. You can't use ActiveX in the other browsers. To disable it, the defenses are disabled, but there's an awful lot of stuff that now need ActiveX controls, particularly stuff that are Microsoft oriented. Cross-site scripting, an attack malicious code is inserted into a specific type of dynamic web page, involves client-side scripts written in Java or ActiveX designed to extract information from a victim and pass the information to the attacker targeted to the website that dynamically generated a web pages to redisplay or echo the user input that has not been properly validated. All these are things that can be done. Cross-site scripting, that's one of the things that the new browsers, I think, will warn you about. And what it's trying to do, again, is steal information from one site and send it to another site.
You know, a whole lot of websites do that.
Whole lot of websites do, because they want to find what you've told the other guy.
Yeah, but like, I know Wikipedia, like, you'll find like 6 or 7 other sites that use the information directly from that site.
Yeah, yeah.
That's stupid.
Embedded code. So a fake email, unsuspecting users, the unsuspecting victim clicks the attack URL and enters his name and password. A number of ways to do that, but each of them is trying to get information. And the examples here, invalid login, please verify your username and password. You've got to put your username and password back in. The invalid, the direct admin login page, the name is provided for you when it comes back. That's the echo that they were talking about in the previous slide. Attacker finds a vulnerable website for cross-site scripting, and they used to call this CSS. They call it XSS because CSS is for page configurations in HTML, standard page configurations. Yeah, cascading style sheets. Yes, I'm not an HTML kind of guy. So, bad login name, fake name. Username, password, the password forwarded to the real server. It asks you to do this. And when you do these things, you're probably going to get your actual real information, except it's going to be passed to the other guy, the password sent to the attacker. So we find this thing, the attacker creates an attack URL, http://fakesite.com login.active service page. Fake email sent to the user with the attack URL, clicks, and goes to these things. I think that I've got one. Let me get to my email account.
Someone figured that out.
So, well, how do they get the account information? Sometimes they just send just, just general. May or may not be, they may or may not know it's a real one. I get emails about my bank account from banks that I've never even stepped into, let alone have an account with, huh? Get calls like that all the time, yeah. Something wrong with your pass? Come on, we need to fix it for you, right? Yeah. But I get them from banks that I don't have an account with, so this may be one that they just generalize send. One of the chapters talks about buying email addresses. You can buy millions of them for $5 or $10. And they just send them. How much does it cost the spammer to send an email? Hardly anything. What does it cost? The amount of time it takes. Because you don't pay by the... If you mail a letter, you got to put a postage stamp on it, don't you? If you send a piece of spam, do you have to put a postage stamp on it?
Not yet.
Not yet. And that's exactly right. Not yet. Not yet. Would that slow spam down? Yeah. Would that irritate us? Yeah. Because there a right or wrong answer to any of these things? There's something somebody's got to agree to, though. Because we spent a lot of money trying to filter it and then to get rid of it. But if I had clicked on that link in that email, then I'll bet you I'd go through this process right here. I'd go to their fake website, which would probably look pretty good. Well, they did that. They sent me the email, and now I click on the URL. It goes through them and still opens the account. Opens the account so that you're not suspicious about, boy, did I just give away my credentials. So those things and emails, and typically reputable companies don't put a login link in the email itself.
So when I have someone call in that says that, because they always go to the website.
Yeah.
They say, well, it looks just like your website.
Yeah.
They click that link.
That's exactly right. That's exactly right. Now, a lot of times, and I'm going to say all the time, and I won't say it's necessarily with that one, a lot of times when you click that link, not only does it go there, but even if you put it in wrong, it says, hey, this is a valid account. We can keep attacking this email address because it's a live email. A lot of spam goes to emails that just go into nothing.
So it doesn't compromise their computer, but it just
No.
sends them up for spam.
Exactly. Yeah.
I probably shouldn't tell them that.
No, probably not.
It's just like when you unsubscribe, you say unsubscribe, they're like, oh, this is active.
Yeah.
Defenses, both webmasters of legitimate sites as well as users should check all user input is validated, that the attackers don't have the ability to inject code, should ensure that web services and database software is patched to prevent cross-site scripting, should never click on embedded links in emails, and this is part of the education program, and it's one of the hardest things, I think, to get across to people. Just don't do it. Don't click on it. If you just want to click on it for curiosity to see what happens, yeah, you could go there and put in false credentials just to see what happens, to see if it actually does try to go there and gives you a bad logon. AOL, yeah, fake at AOL.com. Let's take a break since I'm putting everybody. Hardening web servers, and one of the topics here, because their exposure, obviously they're going to be the target of attack. What can be attacked on a web server? Just about anything. What can be attacked on a web server, Brandon?
Say what?
What can be attacked on a web server? Why would you attack a web server? Hmm? Denial of service? Well, why pick on the web service?
Because if you saturate the bandwidth, you prevent other people from using it.
How about because it's available? What do people set in their DMZ? Do they set their Active Directory servers out there? We hope not. Do they put their databases out there? Maybe, but probably a front-end server. But what's there is the web server. And you're talking about denial of service. What else would you really want to get off of a web server?
Cached password.
Huh?
Cached password.
Cache passwords. How about just access to something that a database controls, like your bank account? And that's kind of what SQL injection is. SQL is, these database guys know. What is SQL? Structured query language. What does it mean? What is it? That's a really, really cool thing for you to bring. What is it? Storing stuff. Database storage, is it not? Structured query language, so we can query the database. What if we could fool the database? SQL injection is one of those things to do that with language used to view and manipulate data that is stored in a relational database. Why is that significant? Because that's where all the usernames and passwords are stored, in a database of some sort. What's Active Directory in its basic sense? It's a database. What is the password list in your Linux machine? It's a database. Encrypted or unencrypted. Hopefully they will be encrypted. Hardening the web servers, forgot your password, and this is one of the ones, by the way, I put the source files for WebGoat in a separate folder in the labs link. It says WebGoat. But it goes through one of those. Forgot your password. What do they ask you for, forgot your password? Email address sometimes. The one they like to use is, what's your favorite color? Well, you just go through all the colors until you find one. What are the questions you answer? Where were you born? Where did you and your spouse meet? Things that people probably could find out. This one, forgot your password. What are we going to send back on the web form? Variations of the SQL attack, deleting data, accessing data, retrieving data. There's a link on the course page for an SQL tutorial. One of the ones that I think is kind of interesting and may not be able to see it real well, so I'll try to talk through some of it, because this is as big as they made it. In this demonstration, you'll see an example of an SQL injection attack. So they're going to connect as HR to create procedure for processing user logons. HR is the name of account, and once they tell you what you're going to do, note the simplicity in demonstrating the SQL attack. In this example, stores user passwords in plain text. Don't do that. In a production environment, follow the Oracle database. This is from Oracle. So we're going to log on as HR. To display the output in the SQL, plus we need to give it some instruction, and they've done that. The name SQL injection value as an injection vulnerability, and then they have the statement there. You can watch this thing and read it and stop it as you go. Let's test the procedure using legitimate values. They do that. The logon succeeded. Yes, we would expect it to with legitimate values. Test the procedure using an invalid value. The logon failed. And now we're going to put in something and then or 1 equal 1. And row, huh? That's a hacker trick. And voila, we're in. Why did we get in? One, it's not really well configured, but we did the or statement. We put in something here, the email address, whatever they're using, or 1 equal 1. 1 equal 1 is a true statement. So the not well configured SQL database said, okay, so you're in. Now you've successfully done an SQL injection. A lot of these things we talk about, oh yeah, it's really complicated, and you're on, you got all the streaming stuff like they show on TV. Some of them are pretty basic attacks. Take a look at that one. Gives you a little bit of an idea. They've got a number of attacks in that tutorial that they show. So, the hardening the web servers, the defense, validate all input, check the inputs, validate the inputs to see that they're used, prepared statements instead of allowing the user to type in a statement, have them choose from one of the predefined lists when possible. This is the what are you going to allow to happen on the password resets, things like that. Assign minimum privileges, and that's always the case. Use stored procedures, store the SQL procedure in the database itself, and don't allow users to create their own SQL syntax like they did, not we did, they did in that attack. They have, and again on that WebGoat, if you play with that, they've got an SQL injection attack on it, and it is an intentionally insecure website that allows you to practice some of these things if you're getting ready for the Security Plus or other security tests. We talk about these things and what are they? SQL injection sounds really, really, you're going to have give somebody a shot with a needle or something like that. It can be something as simple as the quote, or 1 equal 1. So either one of those, the or statement, whichever, and with 1 equal 1 is a true statement, so it says, okay, we're fine. That's one that's probably going to be protected against everywhere. Communications-based attacks, protocols, and application could also be vector attacks. Communications here, messages, emails, SMT, open relays, instant messaging, and peer-to-peer networks are all things that can be factors. Email, we have two protocols that we predominantly use. SMTP to send emails. Emails are forwarded from server to server using the SMTP protocol. And then we get them typically on the POP3 protocol, port 110. So what can happen in SMTP if we have an open relay, and then I was going to go back, what's a relay? You have to send the email to an email server. If the addee is on that email server, it simply sends it to them. But what if they're someplace else? What if you're sending an email from your students.ecpi or students.skyline.edu account to cox.net? The cox.net address isn't on your email server, so it has to be forwarded. An open relay host, an open SMTP relay, is one that takes emails from anybody, which means that it's a great place to send spam from. If you're an open relay host, there are people on the internet that will blacklist you and just simply take your email server offline if you really do become a spammer. They block you for 24 hours, give you notice, say get it fixed, and then we'll let you back on. But you've got to go through some procedures before they'll let you back on the internet. Instant messaging and peer-to-peer networks. Instant messaging, you usually go to a web server to get the addresses, but instant messaging, you become a one-to-one, a peer-to-peer connectivity. And they're talking about peer-to-peer networks here. Peer-to-peer is peer-to-peer file sharing networks. Instant messaging, the problem with it, and there are some virus checkers that will do some virus checking on now, is typically they're unchecked with virus checkers. The other issue with that becomes legal from a networking standpoint. If we let who we pick on today? Let's pick on James. If we let James use an instant messenger and he threatens somebody, the threat came from a corporate machine. The corporation is going to have some liability. Similar circumstance on a lot of the other things. The peer-to-peer networks, we'll kind of worry about viruses. So let's go through these things. SMTP port what? Now that I messed the ports up early on. This one I got, 25. 25. POP3, 110. The other one is IMAP, port 143. IMAP doesn't actually download the email. And in a corporate environment, that's the one you're probably going to use because you have some requirements that you maintain in certain circumstances, that you maintain copies of all the emails. Those certain circumstances, if there's a lawsuit against the company in any form, you have to retain all the emails. If you're using POP3, you ain't going to do that because POP3 actually downloads the email, removes it from the email server and puts it on the desktop. Well, but the receiver does the configuration. It's not something that you as the network administrator is going to control. And if you've got to maintain a backup copy of all these emails, then you've kind of got a problem because they get downloaded. IMAP is the protocol that's typically used for that. The emails stay on the server, but you can do all of the folders just like you do with POP3. You can download copies of them to the desktop so that if the server goes offline, you still got copies of the emails that you can read just like you did with POP3. So IMAP, again, is the other one. This is just the magical thing that I tried to explain, but they've got a nice picture here. Email sender, we send the email to the SMTP server. The SMTP server then relays it across the internet to the domain, and if you remember, MX records are sent to domains. They have two records. One is an MX record, a mail exchanger record, and the other one is an A record for the individual computer name itself. So we get to the SMTP server, which then relays it to the POP3 server. Frequently, the SMTP and the POP server are going to be running on the same server, although they show them as separate. They're separate services, but they're probably on the same server. And then the user downloads it from the POP3 server, from the POP3 servers on port 110. SMTP relay, the servers forward email sent from one email client to a remote domain. If we send it from skyline.edu to cox.net, it's got to get from the skyline.edu domain into the Cox domain in order to deliver it to that user. An open relay is one that's uncontrolled, and there are configurations in the SMTP to specify who you're going to take emails from. Are you going to require authentication, for instance? Most of the people at Cox, you don't have to do authentication, but you can configure SMTP so where you have to use a username and password to actually send the emails to the SMTP server, your own SMTP server. One of the defenses, just turn it off, probably not one that's going to work very well. Instant messaging, real-time communication, and this is something that started out with, I know when my son was growing up, Interstate IM was the thing. If you didn't have an AOL Instant Messenger account, that was nothing. Now they're all texting. But this is something that corporations have adopted from that era to use messaging within the company. One of the ways to protect yourself is you set up your own messaging server instead of using an external one. But you can chat several users at a time, send and receive files, and to receive real-time stock quotes, news, on and on and on and on and on. The issue is that these are actually users that are connected to your computer. You don't know what's on the other end. You can get infected relatively easy. Direct communication between the user's computer is not encrypted by default, so you can see all of the traffic that goes through these things if you can intercept it. They love to say, you can see everything. Well, that's all part of other configurations. How would you configure your network so that everybody couldn't see everything? What's the easiest thing to do? How about putting in a switch? Who can see what traffic on the switch? Whoever's in the broadcast. It's probably not broadcast traffic. So it's probably unicast traffic. And you only see the unicast traffic to you. You don't see everybody else's unicast. So, I mean, yes, you can. And can we configure it? Can we run other things that can intercept that traffic? Sure. That's why, and I keep saying, what are these other things? And they say this and they say that, and how can you break this or break that? There are lots of ways to overcome a number of these vulnerabilities. Now, the direct connection, viruses, worms, and those sorts of things, typically that's not going to be, because that's a direct connection. My computer is connected to your computer. Keep the server within the organization. Don't go outside the firewall. This is the run your own messaging server. There are virus scanners, for instance, in Messenger, and don't allow file transfers, because that's where Devin was talking about the transfers. That's file transfers that don't go through a virus checker is one of the ways that you're going to get yourself infected. Peer-to-peer or direct connection between users don't have servers, and torrents are that way. When you're on a torrent, you're connected to a lot of different people.
What about like websites? If the URL's even in there, they'll try to get a Trojan.
Yeah.
What do they use for that to launch it automatically? Is this the way they just put it on the website? So if you went to that URL,
Well, it could be, but it's like JavaScript,
that's what they do.
ActiveX, and there are a number of ways to do that. Typically, what they're going to try to get you to do is to do something to actually invoke it. I have this really cool program. Want to try it out? And you double click on it. You don't have a really cool program, but now you have a Trojan or a virus. We didn't do a real good job of tricking you with SF7, but you had to run the executable before it did anything, didn't you?
Once you run an executable, it continues to run?
Yep. Till you turn it off.
Till you shut it down?
Till you shut it down. Yeah, or turn it off. Now, how will we make it come back? Put it in the path, put it in the startup.
So you could enable it like a device to automatically start running?
Well, you put it in the startup folder, so that it started when the computer started. Yeah. That's one of the reasons you want to use MS Config every once in a while, to see what's actually starting when your computer starts up. Hey, I didn't put that in there. Well, somebody did. Something did, yeah. Lots of different things that you can check. What's going on? And the services, when we talk about baselining, look at the services to see what services normally run on your machine. Make a list of those so that you can go back and say, where the heck did this come from?
When the one computer was having so much trouble with it, they'd actually turned the security service off. And I went in there and I was like, that's strange.
Mm-hmm.
That's when I started looking around.
Yeah, start looking around for everything. And a lot of these, and James has pointed this out, on some of these really nasty ones, particularly the ransomware, they turn off stuff, and Chris was talking about that too. They turn off stuff like you can't start Task Manager, you can't run Windows Update, or MS Config. Yeah, yeah. So they really shut down a lot of stuff. Point-to-point typically used for connecting devices on an ad hoc basis for file sharing, and I think Instant Messenger has that ability, has the file sharing ability to do those with. Easy way to get infected. BitTorrents are a way of doing peer-to-peer, but like we were saying earlier, it's a little bit more difficult to get viruses from them because you don't get the whole file from an individual location. You get parts of a file and the torrent then puts it together. Internet connections are available through a tracker. The tracker doesn't actually have the files. The tracker only maintains a listing, basically, of what's going on with these things. The files are advertised. The BitTorrent cannot be used to spread viruses, malware, like a traditional point-to-point networks. And again, I don't like the words in security particularly, cannot, will not, will ever, always, because that's not going to be the case. Can you get a virus from a torrent? Sure, if everybody's got the same file, it's got the virus in it, you're going to get the virus. The odds are reduced that you'll get a virus, but it certainly doesn't make it impossible. Patches, software, patches, yeah, we already did that, didn't we? Software security, antivirus, anti-spam, pop-up blockers, personal firewalls, host intrusion detection systems, probably just kind of mention those antivirus softwares. And one of the things that I did ask you to do in this chapter before you start doing all the does it detect it, since there's not an antivirus software on the machines as they exist, go ahead and get free AVG and install it, because a number of the activities ask you what happened with the antivirus program when you got these things. Did it detect it? Did it not detect it? Use anything, but free AVG I know is free. I'm not going to ask you to buy an antivirus software. Well, it depends. I've had some things that it'll detect it, other ones wouldn't, and I've had some things other ones would detect and it wouldn't. Does any of the antivirus softwares detect everything?
Malwarebytes detects a lot more.
Malwarebytes does a pretty good job. I agree. Yeah, Malwarebytes, and feel free to use it. Malwarebytes is available freely. It's a freely distributed program also. And if you're not using it on your own machine, you may want to consider using it. It does find an awful lot of stuff.
It's done more than Norton.
Find more than Norton, yeah. Depends on how they're written and what's going on. We've had pretty good luck with Sophos, but I don't know how much it costs because they really go for the corporate market. They used to have individual subscriptions, but they've kind of done away with those. What's the safe way to do that? Don't go on the internet. Use a virtual machine for your internet surfing. And then if it gets infected, delete it and use a different virtual machine. There are a number of ways around this thing. Antivirus software use definitions. That's why they're not perfect. They use definition strings that resemble what the virus, that define what they think the virus is going to look like. It's kind of like the spam filters. They're looking at strings of characters for the spam filters. They're looking at particular program entries for these things. We can clean it, delete it, or tell it to do nothing. So they're all configurable. Pop-up blockers, kind of handy. Keep you from nothing else being annoyed, but occasionally you have to have that pop-up when maybe the logon screen won't pop up. Or in what I have, the pop-up blocker in Chrome, the messages from Moodle won't pop up in Chrome. But they will in the other ones because they're configured to allow it. I just haven't got it configured yet. Limit block-ups, you can block whatever you want or allow pop-ups on whatever you want. Turn them on, turn them off. Again, it's not an all or nothing. Play a sound if you really want to know. Show information bar. That block the pop-up. Here are your options, and usually allow pop-ups on this site forever or temporarily allow pop-ups. Temporarily would be for that session. Anti-spam. Spam filters on the SMTP server, spam filter on the POP3 server. The SMTP server actually makes more sense because that's where the mail's being transferred. If you do it on the POP3 server, it's already been delivered by the SMTP server, so you've used those resources. Might not be downloaded to the user, but it has been transferred. There are a number of spam filters. There are a number of virtual spam filters that you can get. VMware has several of them already installed, ready to go, ready to configure that you can use. Third-party entity filters out spam. All the email is directed to the third party, and it does the filtering, so you're actually paying somebody to do your filtering. What that does is the MX record, by changing the MX record, to send it to that location, and they send it back to you. Local computer, we can have the block centers, allowed centers, block top-level domain lists, and junk mail protection, how far you want to go into that. And then the Bayesian filtering, which are third-party programs that you put on the machine that will do the spam filtering for you. Install a separate filtering software with the email client software. What they do, they call Bayesian filtering. It compares what you say are spam and what you say are valid emails and looks for word entries in those to make a determination of whether it's valid or not. Personal firewalls. Who uses the personal firewall on your computers at home? I don't. I should. I don't. I know. It's just kind of a pain. But there are advantages and disadvantages to each of those things. The advantage is that if part of your network gets infected, then you've got that firewall to protect it rather than being attacked from outside. And for those of you who did the forum, inside, outside, a lot of the threat comes from inside. An awful lot of the threat comes from inside. Oh, you can always do them. You just get lesser and lesser and lesser credit the farther it is away from the due date.
Where's your Christmas spirit?
Where's my Christmas spirit? I have Christmas spirit. I could just say no. That would be no Christmas spirit.
It's in his other bag of, his other pair of socks.
So personal firewalls, and Windows comes with those. There are a number of those that you can download also. The new Windows firewall, if you go to the advanced firewall settings, it's pretty good. You can go right down to the port. If you just open a firewall, it's kind of the standard selections. Let this application in, this application out. Advanced firewall settings is actually a true firewall control. So don't be fooled into the just firewall. Go to the advanced firewall when you do this. Host intrusion detection systems are things that detect attacks. They can warn you, but typically what they're going to do is warn you after the attack has happened. A host runs on the computer. We've got a host intrusion detection system, a network intrusion detection system, as well as prevention systems. Prevention systems are the ones that you really want because it stops the attack. The detection system reports that the attack has been run. Host intrusion detection system, open source, freely available, is one called Snort. Well, it also has a log analyzer called ACID. Actually, ACID's no longer maintained. There's another one, but it used to have Snort and ACID. They ran together, huh? Hey, these things are all written by old hippies. Yeah, but you can run that. It'll run. It's designed. It's a Linux-based. You can run it on a Windows machine, and it will watch for infections. It's the only one that I know of off the top of my head that's free. Snort.org. They also have a number of webinars that you can watch there. If you can, I've tried to watch them. These guys are really very good, but they're really very technical on how they do those things. Systems can be divided into 4 groups: file system monitors, log analyzers, connection analyzers, and kernel analyzers. What is the penetrating software trying to do? So trying to get in the file system. Log analyzers, if the logs are turned on, an awful lot of stuff gets logged, but we don't look at them. So the log analyzer looks for things that have happened that have been logged that we might not have seen or just didn't do the log analysis. works on the principle of comparing new behavior against normal behavior, so normal has to be defined. Again, this is another system that has definitions, and those definitions you can write your own, but they have to be kept up to date. And they have new definitions that come out on a regular basis. So what are you going to do to protect your system? What do you do to harden your system? What's one thing you can do to harden the system? Say what? I didn't hear you. Disable unnecessary programs. Same thing to start with. That is a great way to do it. How do you determine whether it's unnecessary or not? I tell you how, that's the way I do it. Turn it off. If nothing happens, it's probably unnecessary. If something happens, turn it back on.
Call your neighbor, come walking through.
Yeah. There are sites available that will tell you what unnecessary things. There are a number of things unnecessary. If you have a computer, a desktop, and I'm going to get myself in a trap here. That's a wired computer that doesn't have a NIC card. Do you need a wireless service running? Probably not, unless you use an 802.1x. Then you have to have the wireless service running. That's why I say I don't get myself in a trap. But the wireless service starts automatically on all these things. Do you need it running? Probably not. Do you need all those services? Probably not. There used to be and I guess it probably, I don't know if it was, I looked at it one time, it was called a Black XP. Somebody had taken it and stripped it down. Boy, it ran good.
Oh,
It ran good. Wouldn't update. It didn't have a whole bunch of stuff on it, but it was quick, and it didn't take a lot of memory.
what was that one with the big mushroom on it?
Yeah. Yeah.
What was that?
But disable unnecessary services. Disabling the unnecessary services also reduce your attack profile. The fewer ports that are open, the fewer places they're attacked. It's just like your house. If you've got 14 doors, you got to remember to lock all 14 doors at night. If you got one door, you only got to remember to lock one door, and you only got to worry about one entryway. Machines, computers, networks are much the same way. What goes on with them? Questions? So everybody's going to go home and secure their networks, right? And get web goating. Do SQL injection.